Hello, welcome to Astronomy Live. Tonight, I'm going to be webcasting the close approach of Asteroid 2012 TC4. Right now, I'm just finishing up the telescope setup. The telescope's aligned. I'm just going to be working on focusing the camera here over to the asteroid, so stand by. All right, just to give you guys an update, the camera's powered on, and I'm just waiting for it to cool down here. And we'll be focusing on the rival of Mars. Bragging rights to the first person in the chat who can guess what star that is. And for those wondering about the music, it is provided by Stellar Drone. This is from his latest album, Between the Rings. Okay, let's do 2x2. Save off. Let's just see how this looks. Now, I have rebaked the desiccant plug for anyone who is viewing the last webcast. You might have noticed that things didn't exactly go according to plan. And one of the things that didn't go according to plan was the desiccant plug was saturated, so I wasn't able to properly cool the camera. So the image you're now seeing, the barbecue grill, as I like to call it, is an out-of-focus star with a focusing mask on the front of the telescope. And this helps achieve perfect focus. I'm not going to get it too perfect here because I'm going to have to slew the telescope significantly to reach the asteroid. So we will actually slew to a secondary focusing star closer to our main target. I just want to get roughly correct here. The idea is to make the center vertical line symmetric in the middle of the X formed by the other two diffraction spikes. When you do that, you're in perfect focus. I'm actually downsampling the resolution of the images 2x2 right now. Okay, that's good enough, which is also why the images are black and white, but it gives us enhanced sensitivity. Okay. Camera's still in the process of cooling down. It's just now passing the 0 degree Celsius mark. Okay. We can go ahead and go to 1 by 1. I just want the center of that image. 1 by 1. Okay. This star is Fomalhaut. There's a bright star in the southeast right now. I went too far with that focus. I gotta come back the other way. Come on. Thought I went too far. Did I go the wrong way? I'm going the wrong way still. No, now I'm going wrong. I was going the right way a moment ago, I think. Yeah. Yeah. Too far. Getting a little too eager with it. Trick is to make slow adjustments. It's easy to get impatient when you have to wait a full second for the picture to take and another second for it to download. But this is a Batinov mask that makes these diffraction spikes, and it is very handy. I highly recommend getting one if you're using a telescope for astrophotography, especially deep space astrophotography like this. Okay, the camera has been at -5 now for bits, so I just want to check and make sure that we're not getting any sort of frosting. The camera is actually cooled to -5°C, and if there's any humidity left in the CCD chamber, it will crystallize as ice crystals on the CCD, which is not good, obviously. I don't see any signs of frosting, which is good. That means my desiccant plug bake out worked. You literally bake the desiccant plug in an oven for about 4 hours to get all the humidity of it out. It's reusable, but every 6 months or so you have to rebake it, at least here in Florida, which is really quite humid, obviously. So it's a bit more of a persistent issue for us than perhaps more northern, more arid states. Normally it should be about, I think, a year between desiccant plug bakings. Okay, wrong. That's better. Okay. I think we're going to call that well enough right there. That looks pretty symmetrical. Good. All right. So what I'm first going to do to track the asteroid is I'm going to fire up TeleTrak, which is my custom-written software for tracking fast-moving objects with telescopes, including asteroids. I'm going to take off that focusing mask here. Okay. And now, what I need to do, develop what COM port the telescope's operating on right now. And I'm actually going to be using amateur data to track the asteroid, at least initially. So my program will accept input from FindOrb which was used to calculate the orbit of the asteroid. And let's see here. And now it's also going to accept JPL data as well. But initially, I want to start off here with, let's see. All right, we should be tracking. So let's go ahead. Let's turn on autosave. This is going to be 2012 TC4. We'll do 1 minute at 2x2 binning. Okay, 1 minute, 2x2, auto dark, no subframe. Let's go for it. All right, first picture coming up, hopefully, of the asteroid. So did anyone get the name of the star? I haven't had time to look at the chat until now. Don't see it. Somebody may have said it, but I don't see it in the chat. Anyway, the rival of Mars, Antares. That was the first focusing star. Yeah, there is no chance of impact on this orbit or any time in the foreseeable future. Now, the orbit was much more uncertain before the asteroid was recovered in late July. And initially, we weren't sure whether it was going to be passing a few thousand kilometers or, ooh, it's really out of focus. I'm pretty sure this is the asteroid right here in the % sure, but that probably is. However, the image is way out of focus. What that is mirror flop, unfortunately. I'm going to stop the tracking. That's what that awful music for less pain to the ears here in a bit. But first, let's get things situated with the telescope. So I stopped the tracking. I'm going to stop the auto dark. That's pointless. Let's take just the best thing to do is to focus on the field of view that you're actually going to be pointing at, if at all possible. However, sometimes there's no bright stars that are really suitable for focusing. That's why we see these big blobs right now instead of sharp points of light. We're looking at out of focus stars. So I'm just going to take this swath right here. Good 1x1 binning. Oh. Always late. Going to put the focusing mask back in place. Okay. Sorry, folks, we got to refocus again. Unfortunately, because these stars are not nearly as bright, it's going to take a longer exposure to get them in the image. So, okay. It's the right direction. Sure. Let's get in there. Problem is, I may not even have a long enough exposure at this rate. Yeah. I can just barely see the diffraction spikes, like the very tip of the diffraction spikes, which is why the stars look like they have wings right now. Okay, I'm gonna have to increase this. Tell you what I will do though. Actually, let's do a 2x2. If I bend the images, we won't have as much resolution, but we might have more sensitivity to pick up more of the diffraction spike. Eesh. It doesn't really help. The loss of resolution is too severe. So, and that was a dumb idea. Okay, let's go back to 1x1 binning, but use 10-second exposures and just see if we can get more spikes. I mean, honestly, this is probably overkill since we're going to be doing 2x2 binning to image the asteroid. Any real big difference from having it slightly out of focus, because we're cutting resolution in half anyway. Okay, let's just see how that looks. If that looks reasonably good, then we'll proceed. It looks reasonably good. I actually went a little too far, but I'm going to leave it. I should have. Did I turn off autosave? I can't remember if I did. No, I didn't. Okay. Well, just start a new series. Okay, sub exposures. Let's resume tracking. Okay. Here we go. This is an 8-inch Meade LX200 Classic. Definitely not a 14-incher, but much more portable and easier to set up. And that's right, this is an LX200 Classic, which isn't even supposed to have the ability to arbitrary velocities like this. But I was able to find a workaround that I implemented with my software, which is why I'm able to track this asteroid directly instead of just letting it fly through the field of view, playing leapfrog with it all night long. There we go. We're in business. Right there is the asteroid, 2012 TC4. It's that little bright dot right there. Fantastic. And this is being tracked using just amateur data, collected both when it was discovered in 2012 and more recently, in the last month. It's been observed by amateur scopes. The initial amateur data came from Great Shefford Observatory in the UK. Other amateur data was provided through itelescope.net, as well as other amateur astronomers. I'll include a link to the actual orbital solution that was generated from amateur data in the video description. And it also shows you how it matches to the professional data. That's got to be it, though, right there. It's well tracked. And it is a bit jagged. That's because of the encoder resolution of the telescope, the limitations of that. No, you cannot see it without a telescope. It is far too dim to be seen by naked eye. It's around magnitude 13. Yeah, that is it. Fantastic. I did some troubleshooting on the software. We had some bugs and glitches with it last time during the flyby of OSIRIS-REx. Finally got those bugs fixed just in time to catch it during the last 15 minutes. And that was an image that I included in that last video I put up showing my orbital calculation for the OSIRIS-REx spacecraft. But the workaround I fixed during the webcast was very much a temporary fix. It was a sort of jury-rig solution. It wasn't really an elegant solution, and it would not work in all cases. Just that particular case, I forced the solution. But I came up with a much better solution over the weekend and put that into the software. Sure enough, it works. It's tracking great. The issue was it had a bug with the way it was reading and sending commands to the telescope if an object was in the southern celestial sphere, which this object is, and so was OSIRIS-REx. So I had to come up with a better workaround because the telescope did not like what it was being told. It's kind of silly, but it was being told declination, and when declination went negative, it gave it in negative degrees, negative minutes, and negative seconds. So it had 3 negatives in the command it was sending, which is not proper formatting at all. And it did not like that. That was the main problem. So anyway, problem solved. And let me see if I can pull up. I've got a link to the orbital solution that this thing is using right now. Again, comes from amateur data, but the professional data is shown alongside of it for comparison. And you can see that the amateur data is a very tight fit to the professional data. Professional data is excluded from the calculation, but the residuals, the amount that it deviates from what the orbit predicts, is shown in parentheses. And the actual astrometric observations are that were excluded have an X marked next to them. Only a few observations from a few amateurs are included, and it's just ones that I knew off the top of my head were amateur sources. I'm going to go ahead and paste that link in the chat right now for anyone who wants to take a look at it. You can download that HTML file, and we'll show you the ephemeris for this asteroid predicted by the amateur data, which again shows that there is no risk of impact. The closest it's going to get to us today is about 50,000 kilometers, which is pretty darn close, but not any risk for impact. Let me see if I can go ahead and edit the video description here. I don't normally do this during the middle of a webcast. It looks like it'll let me. Pop that in there. There we go. So we're running 1-minute exposures here. I think they said the asteroid has a rotational period of about 15 minutes. I could be wrong. I think it was about a quarter of an hour. I mean, it's pretty quick, maybe even faster than that. And there's some speculation I was reading in some articles that Earth's gravity might be so significant for this asteroid since it's getting so close that it might actually alter the rotational period. I'm guessing probably because of gravity gradients. Spacecraft experience this all the time, and some of them use it to their advantage, where one side of a spacecraft that's closer to Earth actually feels very, very slightly more gravity from Earth than the side of the spacecraft that's furthest from Earth. And so because of that, it will assume an equilibrium position oriented in a particular way where it's balanced. And that torque can potentially affect small asteroids as they fly by Earth. So I know there's going to be radar observations of this asteroid both before and after the close approach to see if the rotational period changed at all. We might potentially be able to see some hint of the rotational period just in how bright the object is. As it rotates, that brightness will fluctuate depending on how much surface area of the asteroid is reflecting light towards us. An asteroid this small, it's about 20 to 30 meters, maybe a little bit bigger, maybe a little bit smaller. But something that small is probably very lumpy in shape. It's not going to be big enough to have formed hydrostatic equilibrium, meaning assume a spherical shape under its own gravity. So that lumpy shape obviously can produce significant fluctuation in the brightness, even if the surface were all the same color. The lines in the image are stars streaking by. You can see there's quite a few stars, and they're streaking quite quickly because this object is moving quite quickly. Keep in mind, the field of view here, the width of this field of view from left to right, is approximately the same as the width of the full moon. And so in just a few minutes, this thing has already covered one full moon's width in the sky relative to the stars. We're not even talking about the rotation of Earth here. This thing's moving quite quickly. If it were a distant asteroid, very far from Earth, moving very slowly in the image, then it would seem to be stationary relative to the stars. Normally, this telescope tracks with the rotation of the stars, but this asteroid's moving very quickly relative to those stars due to how fast it's moving and how close it is to Earth right now. Quite cool. All right, so the dark circles are actually dust spots on the CCD, and that's taken out by flat field subtraction, and that's done in post-processing. So you would take pictures of the blank sky, or you would take a whole bunch of pictures of stars and do sort of a median combine on them to average out the stars and just leave the background light with all these dark circles, and then subtract that from the final image. So yeah, my CCD is a bit dusty, but first rule of maintenance of any telescope or astronomical equipment is do no harm. It's better to just fix that problem in post-processing using flat field calibration than trying to constantly clean your equipment and potentially scratch a delicate glass surface. These cameras are very, very expensive. This camera retailed originally for $3,000. It's more expensive than most amateur telescopes. All right, I will put it back on the music now so you guys don't have to listen to the constant whine of the telescopes. Actually, I can just disconnect the hand controller now. I'm not using it. That's what's producing the noise. That's better. But I will put the music back on because I know a lot of you guys enjoy it. After we track this for a while with the amateur data, I'll switch it over. I'll let you know when I'm going to do it, but I'll switch it over to the professional data, and we'll see if that also lines up with the trajectory of the asteroid. I'll give you a spoiler. It will. If any of you saw that that bright streak that went through the image just now, that was a satellite. We're still early enough in the evening that satellites can pass through the field of view. I'm trying to locate which one it is. It doesn't seem to be coming up in Sky Safari Pro based on the location the telescope's currently pointed at. Oh, location. Why does it think? I thought I was in New York City for some reason. Oh, maybe that was the problem. Playing back which satellites. Whoa, that one came close. That might have been it, actually. That looks like it would have been it. NOAA 18B. Yeah, that passed right through the track that the asteroid was following. I can try to. Unfortunately, I don't think I have this particular asteroid in Sky Safari Pro right now. Let's see if I can scroll down here and find it. No, they don't list. They don't list asteroids that faint, unfortunately. But that's the right region of the sky for sure. It looks like it would have been where the asteroid was located at the time. And the timing looks to be right. Yeah. Cool. Looks like it was launched in 2005. I have no idea if it's currently operational or not, but the designation is 2005-18A. So if anyone wants to know where this asteroid currently is, the coordinates, according to my software, are 21 hours, 55 minutes, 30 seconds right ascension, in declination, negative 20 degrees, 51 minutes, 50 seconds, and increasing. No, it's funny, looking up at the telescope where the telescope's pointed, I feel like I can already tell that the telescope's moved a bit from where it had been. We also have an airplane flying pretty close to where the telescope's pointed right now. It might fly through the field of view, I'm not sure. That'd make for quite a sight if it did. It's got all its strobe lights blinking and stuff. I'm very close to an airport right now, which is, well, I've got a fair bit of air traffic overhead. Nope, looks like the airplane missed. Oh well, too bad. It was close, I could tell that. All right. We're tracking the asteroid. We are tracking the asteroid. It's 2012 TC4. It's a small asteroid about 20 to 30 meters in size, passing very close to Earth tonight. The close approach date, October 12th, refers to universal time. In some time zones, it'll probably still be October 11th when it hits the closest approach. But it actually sets, for my location, around midnight, and I'll be packing up before then. But yeah, that's the deal. I had actually forgotten. I mean, I knew the asteroid was going to be flying by on Thursday, but that's actually Thursday Universal Time. It's a tricky trap because you can forget. Because, yeah, the close approach time and date, October 12th, you'd think that means Thursday night. Well, actually, it means Wednesday night because it's already Thursday by Universal Time. And by the time Thursday rolls around for us here in Florida, this thing will have already passed its close approach point. And it's best to view it now. I don't even think it's necessarily going to be visible from here tomorrow night. So I looked at the calendar earlier today and I thought, oh yeah, Asteroid's going to be tomorrow night. And then I realized, wait a minute, no, it's going to be tonight because Universal Time. Yeah, people are wanting to know if you'll ever be able to see it with the naked eye. No, unfortunately not. It's currently around magnitude 13 or so, and that is way too dim. The dimmest the eye can possibly see is around magnitude 7, and that's with averted vision under ideal dark sky conditions and the trained eye and all the rest. Most people can get to around magnitude 6 with the unaided eye, and this thing is many times dimmer than that. The magnitude scale is actually logarithmic. It's not linear. So it's way, way too dim. To the telescope, it looks bright. That's because this telescope is exceedingly powerful and sensitive. It's an 8-inch diameter mirror, and the CCD is actively cooled to -5 degrees Celsius, and it's actually combining the pixels 2 by 2 for even more sensitivity. So that's why it looks like a bright spot to the telescope, but it's actually quite dim. And yes, it's a 1-minute exposure, so it's 1 minute frame to frame.
Okay, one thing I wanted to point out for anyone new joining us, the dark circles, those are dust motes on the CCD. The bright dot is the asteroid, and the streaks are stars as it flies by them. So the other thing I want to point out, there are some old stories out there, old articles, quoting a very wide range of possible distances. And they said we didn't know exactly how close it was going to get. That was before the asteroid was recovered. In other words, redetected from this new approach, the approach of the asteroid. It was discovered in the year 2012, in October of 2012. It was only observed period during that approach. And so, because this asteroid is so small, it has to be fairly close to Earth to be detectable to most telescopes. And so we only had 1 week to observe it and get data, both amateurs and professionals. And because of that, the orbit, when projecting where it's going to be 5 years later, is quite uncertain. Time is a critical factor when trying to measure orbits and trying to determine what the true orbit of an object in space is. And so no matter how many observations you could have every single telescope on Earth looking at this thing when you first discover it and getting data. But if your time window for observing it is only a week, it's going to be very difficult, if not impossible, to accurately project where it's going to be years into the future. Now, they had a rough approximation of where it was going to be that was, like I said, quite large. Let's see if I can find one of those articles. There's one that NASA put out back in early July that a lot of sites were quoting, even recently. Here it is. Let me pull this into a new window. Then I'll share the window so that you guys can see this. If I can get real fancy, maybe I can share the asteroid while I share the article. Yeah, I can do that. Let's just share the whole screen for the moment. Okay. So here is the article, and this is what a lot of sites were quoting. Even, like I say, within the last week or so, I saw sites quoting this old article from July 12th. And it's from NASA, and it says that they're certain it won't hit Earth, but they're not certain by how much it will miss. That its close approach could be anywhere from 6,800 kilometers all the way out to 270,000 kilometers. And they thought it was likely to be much further away than 6,800. Well, it turns out it's less than 10 times that distance, and nowhere near the 270,000 kilometer number. But that was found out just a few weeks later. In late July, the asteroid was recovered by some very large telescopes that were, I believe, actively looking for it. And it was recovered at a very dim magnitude, well under magnitude 22, 23. I think it was magnitude 26, 28, something like that. It was really dim. Here, we can go to the Minor Planet Center. And this is how you actually pull up data on the asteroid, where you can calculate it yourself if you like. So here is the page on the Minor Planet Center for 2012 TC4. If you scroll down here to observations, if you download this data, you can load this into a program like FindOrb. Oh, there goes another satellite. Let me see if I can figure out which one that is. Over there. Let's see, what are our current coordinates? This is my program. The user interface, pay no attention to it. It's just a temporary situation there. I don't know if it's that one. Let's see here. Oh. Crud. Okay. Ah. I don't know. I don't know that was it. This one might not be on Sky Safari's list. The closest I see is 03BFM8. I have no idea what that is, but it doesn't really look to be close enough to be in the field of view, so I'm not sure what that was. Could have been a classified satellite. All right. So anyway, as I was saying, before I got distracted there, sorry, you can see all these observations from October of 2012. This is the first observation from Pan-STARRS, which is an all-sky survey designed to locate small asteroids like this. It was discovered then on October 4th, 2012. I think they were the ones discovered. Sometimes you'll get observations that actually predate the discovery, where it wasn't realized that it was in the image, but then when it was discovered, they looked back at images from where it should have been, and they find it in pre-discovery images. That does happen, but I'm pretty sure that this is actually when it was discovered. And then it was observed for about a week, and then suddenly you'll see the date on these observations jumps to 2017. And so the first observations were on July 27th, 2017, and it was observed at, look at this, magnitude 26.8. That is extremely dim. And so that tells me they were probably actively searching for it and probably tracking it based on the rough orbit that they had for it. And then from there, it was observed by a variety of other telescopes looking at the asteroid. And eventually, you start to see observations from itelescope.net. Full disclosure, I am a science advisor for itelescope.net, but I am not getting any sort of kickback from telling you that or from promoting them, I promise. But they did observe it. You can rent time on telescopes on itelescope.net and track asteroids like this. So even if you don't own a telescope powerful enough to detect this asteroid, you can rent time on one that is powerful enough to see it weeks before it actually makes its close approach. And so they observed it. SLU, another amateur telescope site where you can rent time on telescopes, they caught it as well. And now here we are. So these new observations in October, which actually stretch all the way back to late July, but even excluding that, even just using the amateur ones from iTelescope and some of the others, that's enough to track it like we are doing right now. That's what the tracking is actually based on, is just the amateur data right now. And this is where you can download all of that data along with all the professional data and calculate the orbit. So those new observations dramatically improve the orbit determination. The uncertainty code, a lot of people like to look at that, is now a 1. So it's highly certain orbit, and the trajectory is very well known. And so we know the close approach distance, give or take a few kilometers now. And that close approach distance is about 50,000 a little more, actually. I think it's about 50,150 or something like that, kilometers, give or take a few. So the trajectory is very well known now. But if you look at a lot of mainstream media articles, you'll see a lot of bad reporting because they keep citing this article, which, as you can see, was published July 12th, a couple of weeks before the asteroid was recovered, or some might say rediscovered, but it wasn't really rediscovered, it was just recovered because we knew where it was going to be. A rediscovered asteroid is one that you accidentally stumbled upon it again and it had been lost for a long time. This one was lost only because it was far enough from Earth that it wasn't really observable, but it was recovered back in late July. So I hope that clears that up, because there's a lot of bad reporting out there, unfortunately. All right. Put it back on just the view of the asteroid. And I think at this point, it would be a good point to switch over to the JPL data, so you can see the difference between the professional data, which honestly I'm expecting will not be much of a difference at all. Oh, here we go. Sorry, I had some issues there trying to get my tracking window back up. All right, so I am going to stop the tracking. I'm going to load the JPL file and restart the tracking. Okay, so in this picture, this should be interesting, because this picture is going to be a bit jagged because the tracking stopped and then restarted. So the stars are probably going to get really wonky looking. But I am going to stop the picture taking as soon as this one's done. I want to get this one just so we can see what that looks like. But as soon as that one's done, I'm going to stop the imaging run and rename the file so that I know that all files after this one are taken with JPL data. We've taken about 45 minutes worth of pictures with the amateur data, and it's tracked perfectly in that time, as far as I can tell. So yeah, you can see the stars there stopped. And hopefully are now restarting. Oh, you know what? That won't work. I forgot to tell it I was actually using JPL data, which is in a different format. Hold on. So it actually just stopped the tracking. It didn't start anything. Okay. Now it seems like it's going again. Maybe. We'll see. Not sure if we're having an issue here. I might have goofed it up because I forgot to tell it. Let's see what happens. I might be having another bug here with the JPL format. That's why you got to troubleshoot it in the field, unfortunately, at this point. See if it really works or not. Because it doesn't seem like it's updating the coordinates that it's sending. Let's see what happens. Oh, it is. It's just being kind of weird. The asteroid seems to be streaking along here. I'll give it another minute to see if it behaves properly. I want to plug in the hand controller again. One of the reasons it makes that tone, or at least one of the reasons it's helpful to me, is that it tells me that the telescope's receiving a constant signal from the computer to engage the tracking. Because I unplugged the hand controller, I don't know for sure if it's receiving that signal properly or not right now. So let me see what's going on. As soon as this picture finishes, I'll stop the tracking momentarily, unless it looks like it's really working, so that I can plug in the hand controller. No. Well, I say that. Actually, it looks like it's working now. Yeah, it's working now. I don't know why I have a theory as to why it was doing that. It's definitely looking now from the program like it's updating the coordinates and saying new coordinates many times a second, which is necessary for smooth tracking. But it wasn't doing that before, which makes me think there might be a slight bug with the way it's doing the coordinate interpolation. But no problem. I can fix that. I kind of have a feeling where that is in the code that I need to work on to fix that. It's just a minor issue. What it really means is you have to wait a minute for it to actually engage the tracking once you hit the start button. I prefer a little more responsiveness, but as long as it works, for now I'm happy. Boom. And look at that. The asteroid's basically in the exact same place in the image that it was when we were using the amateur data. So what does that tell you? That tells you that the amateur data really does agree with professional data. It tells you that the orbit that the professional data produces, the official orbit of the asteroid, agrees perfectly with the amateur orbit. Not only is it an orbit from the professional data, it's actually an orbit published by NASA JPL. That's where this data actually comes from. This is direct coordinates from NASA JPL being fed into the program, and it's tracking the asteroid perfectly. And it's putting it right where it was based on just amateur data that I computed myself, which you can find in the video description. So I'll let it keep running, then I'm not going to plug in the hand controller. There's no point. It'll just vibrate the telescope and mess up the image. Cool. So yes, this means the program is working with both data that you can calculate yourself using Find Orb, or data that comes directly from JPL. So you can track spacecraft that were just launched by NASA, as an example. JPL Horizons is the system that I use to get the coordinates. It's a great website for getting very highly accurate data, both on objects like comets and asteroids, as well as NASA spacecraft, to figure out where they are exactly in space. And you can use that data with this program to point your telescope and track it.
spacecraft with a long way from home. I thought it might be a good idea just after Saturn to have them take one last glimpse home. From Saturn, the Earth would appear too small for Voyager to make a detail. Our planet would be just a point of light, a moving pixel, hardly distinguishable from the many other points of light Voyager would see, nearby planets, far-off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worth having. It had been well understood by the scientists and philosophers of classical antiquity that the Earth consisted of points in a vast, encompassing
It went all streaky right now because I did that. Trying to center it up a little bit better in the image here, so I made an adjustment to the tracking with an offset of 4 arc minutes in declination. Try to get it closer to the center of the field of view. We'll see if that's enough. I might need to adjust it once more here to center it up better. Yeah, I could use, I'll give it another 2 arc minutes. Okay, that should do it. Gravitational pull of Earth is already accounted for in the calculations, both my calculations and, of course, JPL's. I went ahead and put it back on the amateur data, though, just because. But obviously, the JPL data predicts the same trajectory. Yeah, that's. I think that's going to be good enough right back here. And that's a little higher than I would like. Let's see what the next image looks like then. Yeah, okay. That's better. If it'll at least stabilize. That's actually where I want it in the image. So thanks everybody for tuning in tonight. I'm going to keep it running here for a while longer. But this thing's rapidly tracking across the sky. It's actually already about to pass the local meridian here, and it's going to start getting lower pretty soon after that. And at some point, I'd be tracking right into the trees and stuff. So we'll have it on here for a while longer, but just wanted to thank everyone for tuning in tonight. Mom, Dad, if you're watching, thanks for tuning in. All right. It looks like it's stabilizing there near the center of the image. There's our asteroid.
The spacecraft was a long way from home. I thought it might be a good idea just after Saturn to have them take one last glance home. From Saturn, the Earth would appear too small for Voyager to make a tail. Our planet would be just a point of light in a blue pixel, hardly distinguishable from the many other points of light Voyager would see. Nearby planets, far off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worked out. It had been well understood by the scientists, philosophers, and classical antiquity that the Earth was a mere point in the vast, encompassing cosmos.
All right, I'm going to try something with the image contrast here. I don't know if you guys will like this or not. Let's just take a poll here and see. Let me, where's the histogram adjustment? Let's reset it. No, I don't like that. No. Like, I can make it less contrasty, less extreme in contrast to try to make it look less noisy. These are actually high bit depth FITS files. Some of you might know about HDR TVs, like that's becoming the next big thing, right? HDR, high dynamic range. And up until now, all monitors have displayed images just as 8-bit images. They have a very limited dynamic range, meaning the range from the blackest blacks to the brightest brights. And so these are actually 16-bit images, meaning they hold more dynamic range, more information than a normal monitor can display. So you can adjust the contrast to look at certain regions of the histogram, but the monitor can't natively display the full range of contrast that's available in the image. So hang on, I'm going to stop that and then take pictures. I had to reset the picture taking here because it keeps resetting the contrast. I had auto contrast on until just now, so it would automatically adjust the contrast. But there's certain presets here for like low, medium, and high contrast and stuff, and then you can reset it. This is actually what the image normally looks like if you don't adjust the contrast at all. However, again, our monitors aren't able to properly display the full dynamic range. There's a lot more data there, you just can't see it until you adjust the sliders on the histogram. And there's our asteroid. So I can pull this up to that. Pull in the dark a little bit. There. Something like that, you know, so there's not as much noise. Actually, it's the exact same amount of noise. The only difference is it's not as over-enhanced by contrast. Whoa. Oh, no. Oh, no. Subframe. No subframe. Sorry. Boy, that's my fault. Okay, well, it's going to have to retake the... Oh, shoot. It's going to have to retake its own dark frame now. Anyway, I had accidentally left subframe checked, and so what it did is it only took a tiny picture from a portion of the CCD, not the whole picture. It's probably the asteroid there, actually, because I had highlighted it earlier with the box, and that's the region it took a picture of. So I had to stop it, uncheck that option, so the next picture will be a full frame instead of this. But yeah, so you can adjust the contrast with the histogram, and really none of this makes any permanent change to the images, except what I just did here with the subframe. The raw FITS files are unaltered. They're saved on the hard drive, and so I can adjust the contrast later. See, to me that looks a little nicer. It looks cleaner. Oh good, it didn't have to retake the dark frame. That's good. Yeah, to me this looks a little nicer, less noisy. The asteroid's really prominent. What do you guys think? Do you like this view better than what we had before? Yeah, there's like a 0.0005% cumulative chance, meaning if you combine all possible impacts, looking at the orbit way into the future, for today, there's no chance. It's not going to hit. Yeah, a lot better? Okay. I think the consensus is people like this view a lot better. All right. I'm just trying to make it a little, the black's a little darker there. That looks nice. Yeah, that's a nice view. We can zoom in just a little more, maybe, center up that.
Center up on the asteroid there. There we go. You can still see the stars streaking by. You can still see the dust motes, but now it's a little less blown out in terms of contrast. But the images will be processed at the end of all of this to be consistent with each other and put into a time lapse. So the full replay of this webcast will be available after it's over. And on top of that, later on, I'll put together a time lapse of the pictures taken and upload that. Okay, cool.
I thought it might be a good idea just after Saturn to have them take one last glance home. From Saturn, the Earth would appear too small for Voyager to make out any detail. Our planet would be just a point of light, a lazy pixel, hardly distinguishable from the many other points of light Voyager would see, filled by planets and far-off suns. But precisely because of the obscurity of our world thus revealed, such a picture might be worth having. It had been well understood by the scientists and philosophers of classical antiquity that the Earth was only a point in a vast, encompassing
Hey folks, yeah, I'm pretty convinced at this point that what we're seeing in terms of the brightness variations, that really is the rotation of the asteroid. So you'll notice in some frames it will seem to be somewhat brighter, like it is right now, and then in other ones it'll suddenly get dimmer, or brighter than it is right now. And that's what you expect. You expect a varying light curve, a variation in brightness due to the rotation of the asteroid. And it's quite pronounced in this case. It's probably because the asteroid's quite lumpy. And so because of that irregular shape, depending on the rotation, there's going to be more or less surface area reflecting light towards you. And that's what causes it to seem to get brighter and then dimmer. To some extent, it's also going to be affected by how well the tracking's doing. If it's really tight tracking, it'll concentrate the light into fewer pixels and make it look brighter. But I've noticed times that it's not really any bigger than it is now, which again has a lot to do with the tracking in terms of the size, but the brightness itself seems to change. And I've got it fixed here in terms of the contrast. These numbers should be fixed. They shouldn't be, oh, you can't see these numbers, that's right. The Google Hangout isn't showing you the full control set for the camera. But the histogram set values for the black and the blackest part, the brightest part of the image. And it's slowly getting lighter, and that's because the asteroid's getting lower in the sky. So you just have more haze and more light pollution that you're looking through. And that's causing the entire image to get lighter. But it's not really causing the asteroid to get brighter. That's factors like the concentration of the pixels due to the tracking and the rotation of the asteroid. So we seem to be picking up changes in that brightness due to the rotation, which to me is really cool. And I knew from what I'd read in articles before tonight that this asteroid does have very quick rotation. So I would expect to see it changing from image to image, given that these images are each 1 minute long. The rotation period, what is the rotation period for this one? Let me see if I can find that real quick. For rotation period. So according to Wikipedia, in 2012, it was found to have a rotation period of 0.2 hours, or 12 minutes, 14 seconds, of 0.93 magnitudes. That's almost a full magnitude, which, of course, is indicative of a non-spherical shape. And so just like I said, yeah, what we're seeing here, that is definitely, and the size, like the number of pixels it's taking up in the image, is not bigger than it spread out. Because that can happen too if you have really bad tracking on a frame. The light from the asteroid can be spread out over more pixels, making it look dimmer. But that's not what that is right there. The tracking's still solid. And it suddenly got way dimmer. And that's because of that irregular shape. And as it rotates, which again, it rotates according to the observations in 2012, you know, with a very fast period of 12 minutes, that means every 12 images, it would have completed one rotation. Well, close to 13 images, but yeah, that's a very quick rotation.
And so you're seeing a significant portion of that rotation with every single image. And so if it happens to be oriented in such a way that there's not as much surface area directed towards the camera, like right now, it looks way dimmer. And it's brighten up again. And so that's kind of interesting. We're seeing the rotation of the asteroid. Now, if we take all the data from tonight, I could probably measure some kind of light curve for this thing and try to measure what the rotation period seems to be. Now, it could even be tumbling, meaning rotating in more than one axis. I don't know. And if that's the case, it makes it more complex because it won't be a simple sine wave of light increasing, decreasing in a set periodic way. It'll look more complex, the pattern. But we're not just seeing a steady point of light here. We're seeing a point of light that's changing in its character due to its rotation. See, there we go. It's starting to get brighter again. That's all right. I just wanted to point that out because I think people are starting to notice that, and it is quite noticeable here with the contrast set like it is versus before, where it was maximizing the contrast and kind of washing it out earlier in the webcast. Yeah, the shadow is just the dust, and so the little points of dust are probably directly on the CCD, and the bigger piece of dust is a bigger shadow from a piece of dust that's really no larger, but it's further from the CCD. There's a CCD window at the front of the camera, and it's made of quartz, I think, and basically it's designed to pass through the maximum amount of light. It's designed to minimize any absorption of UV or infrared light. But there can be dust on there, and you really don't want to clean it with normal cleaning chemicals. It would be damaging to it. So it's better to just leave it alone. And posts are completely uncalibrated except for the dark frame subtraction. So, yeah, we've got one larger dark spot and two little dark spots here. And there's probably some others throughout the image as well. Because it is getting lower in the sky itself seems to be getting brighter due to sky glow and light pollution and all the rest. It's getting quite low. I won't be able to track it for too much longer before it just passes over local objects like trees and roof lines and stuff. So I'm going to have to bring the webcast to a close pretty soon. But I am going to change the contrast settings here. I just want to change the contrast a bit. Whoa, not that much. That's funny. Where'd it go? Where'd it go, George? Where'd the asteroid go? I think it's right there where there's also a star, so it's kind of blocking. Or it's making it hard to see where it is. There's a brighter part of the star right there, that kink, which I think that kink is the asteroid commingling with a star on the image, so it's hard to see where it is. I was paying attention to the contrast slider while that was happening. I didn't see exactly where it went. Either that or the asteroid just fell through a wormhole and it's gone. I mean, who knows? We'll see it here in a second, I guess, when the next picture comes in. Wouldn't that be funny? Some weird anomaly happens to it. There it is. Okay, so it was just hanging out with that star streak, so it didn't really stand out. Now it's obvious. Okay, so I have changed the contrast settings here a bit from what they were to try to improve the quality of the image. But that means they're not directly comparable with the images you were just seeing in terms of the brightness of things.
Idea just after Saturn to have them take one last glimpse home from Saturn.
So the asteroid is now less than 15 degrees above the horizon at my location, and it's dropping every minute. So we've only got a few more minutes here. It actually sets over the horizon at midnight in about half an hour. Because of the great turnout on the webcast, I decided to try to keep this in. So I hope, but it is going to go into a tree or roof line or something, and we'll lose it probably in the next 10 to 20 minutes at least. Yeah, this, for anyone just recently joining, the asteroid is the bright dot in the middle. the dark spots throughout the image, both the large faint ones and the small dark ones, are dust motes on the CCD or in the CCD. And streaks are stars. And yeah, this object is way too dim to be seen by eye. Currently, roughly 200 times too dim to be seen by eye, even at its closest approach in a couple hours. At best, it will still be 100 times dimmer than anything that could be seen by eye. And that's really overestimating it, but it's actually going to be a bit dimmer than that. So yeah, you couldn't see this by eye at all. You need a telescope to see this. So yeah, enjoy the last few minutes here of Asteroid 2012 TC4. Direct tracking with Astronomy Live. Yeah, if you like this video, please do subscribe for more. I do try to do this whenever there's a significant asteroid close to Earth like this. And I also use the software to track rocket launches, SpaceX Falcon 9, when it launches and returns landing at LZ1. So stay tuned for more videos and more coverage of space and space flight. And no, this is not a patron account. I have no patron, I don't accept donations, I don't accept money, and I don't monetize my channel. There are no ads here. Any ads you see are because YouTube does that automatically. But I don't see a dime of it. So this is just for you guys to be able to enjoy.
On to ground control. A lyricist whose string of hits, in collaboration with Elton John, has made him one of the world's most popular songwriters. Welcome, Bernie Taupin.
Thank you. Good evening. In 1972, when Elton John and I wrote Rocket Man, it became very popular among the listeners. Due to the interest in the meaning of the song, now in 1978 at the Science Fiction Film Awards, I'm truly proud once again to present My Rocket Man as interpreted by our host, William Shatner. Thank you.
Last night, pre-flight. 0 hour. 9 a.m. And I'm gonna be high. As a kite by then. Oh, I miss the earth so much. I miss my wife. It's lonely out in space. On such a tight and I think it's going to be a long, long time. The touchdown brings me back again to find I'm where you think I am. Back home. I'm a rocket man. Rocket man. Burning out his fuse out here alone. I think it's gonna be time to touchdown, bring me round again. Fine. I'm not the man they think I am. No, no, no. I'm a rocket man. Rocket man, burning out his fuse out here alone. Mars ain't the kind of place to raise a kid. In fact, it's cold as hell. And there's no one there to raise them. And all this science, I don't understand. It's just a job. 5 days a week. Rocket man. A rocket man. I think it's going to be a long, long time. The touchdown brings me around again to find I'm not the man they think I am at home. Oh no, no, no. I'm a rocket man. Rocket man, burning out his fuse out here. Hello. And I think it's gonna be a long, long time. The touchdown brings me around again to find I'm not the man they think I am. Oh, no, no, I'm a rocket man. Rocket man, burning out his fuse out here alone. And I think it's gonna be a long, long time. A long, long time. And I think it's going to be a long, long time. And I think it's going to be a long time. And I think it's going to be a long, long time.
All right. We are losing fat.
What's the altitude current? Degrees, almost 6.8 degrees figure. Yeah, and it's going to be dropping. Yeah, less than 7 degrees above the horizon. Dropping almost 3/4 of a degree per minute, or per 2 minutes, so whatever that is per minute. It's late. I can't do math in my head anymore. But what I can see is that fading out, which probably means I'm hitting the trees. Maybe the lowest part of the mirror, but it's bigger, so the lowest part can be blocked while the upper part is still able to see it, which is why you can still kind of see it, but it's very faint. Yeah, so if I zoom out to see the whole image, you can see other dark spots. At some point, you really see the horizon itself, trees and roof lines and whatnot, start cropping up, although they'll be out of focus because we're focused here on the distant stars and the asteroid. But you'll notice the image itself is dimming gradually as that happens. I'm not entirely sure, though, that I've got any blockage just yet, but it is getting really low. So you have atmospheric extinction as well. Through more and more of the atmosphere, the light dims, which is why the sunset doesn't look as bright as when it's high overhead, of course. Same applies to the asteroid. But yeah, it looks like we will be hitting horizon here very, very shortly. We're now at 6 degrees. Hard to see in the dark just how far up some of these trees go in terms of problem for the telescope once it reaches that. Actually, the one thing I might stop the track asteroid. It's already just above center. It's not going to take it very long because it's going to streak. If I'm looking at this right, it'll streak up and out pretty quickly. And at this point, it's so dim, it may not even be detectable once it starts streaking, spreading its light across multiple pixels like this. The only reason we're able to see it at all in this picture is because tracked. Yeah, it doesn't make much sense to shut off the track if it's going to be that dim. Because the instant I stop tracking it, it's going to be invisible. Because it spent a full minute depositing all of its light on this small group of pixels. And even then, it's barely detectable. If I enhance the contrast here a lot, you can kind of see it. It's supposed to be from where it was in the previous frame. I mean, it's really, really faint. Marginal detection there. don't even see it in that picture. Reach the end of the file for tracking. I only let it run until basically it would set. I mean, I only defined or pre-generated the file for tracking to that point. And we're basically at that point now. If not there, we will be very shortly. And I don't even see it in this picture, like I said. I hope you guys enjoyed it. And again, if you enjoyed this video, please do subscribe and check out my other videos. We tracked the OSIRIS-REx spacecraft as it flew by Earth a couple weeks ago. And before that, I had some launch videos and, of course, the total eclipse. So I try to provide coverage of events like this when they happen. Yeah. Thanks for coming, guys. And I'll be posting a time lapse of the asteroid a bit later. And we'll see what comes up next. All right. Clear skies, folks. Have a good evening.